Assalamu alaikum students. Today we are going to discuss detrending. The procedure of removing trend from a time series is called detrending. A trend usually refers to the change in mean over time. Then the data is detrended. We remove an aspect of from the data that we think is causing some kind of distortion. Uh, the data on the determinate time series is also called stationary time series. Now here this point stationary time series uh, is the main uh, term used for determinate data. Okay? Actually, there when we plot the data like here on the graph paper, we see some kind of pattern like this. Now you can see that this trend is upward trend. We can observe the trend by looking at the graph of the time series data. Now we have to eliminate this trend. We have learned three methods of uh, estimating trend, that is the semi-average method, that is moving average, and method of least square, and smoothing method. Lot of methods we can assess trend, or we can estimate trend by trend values. Then we detrend data by taking difference is the original value y minus the trend value, and we are left with detrended data. Okay, now in the next slide, I will show you how to detrend the data. Now going to our next slide, you can see that there are 1, 2, 4, 3, 4, 5, 6, 7, 8, and 9 years, and we have original data and we have trend data. By using the method of least square, the time series is given as in the following table, and the estimated trend by method of least square. Uh, so now what we have done here, this value called original value minus this value, and we are left with these differences. Now these differences are determinate data. If we plot these values and against these values, or only these values, in the next slide we can see that there is no trend. There will be no trend in the data. Let's see. There are three series in the graph. uh, the green one is original value, this one also indicated here, this one, and blue is the trend line, and the yellow is the detrend data. You can see that there is no trend, and because of this, these points move around the x-axis, uh, -2 plus -2 plus -2 plus -2 plus. Uh, Now, this chart is created in Excel. You can also use SPSS software, or Excel. Okay? I will teach you SPSS software in next semester. uh, but if you have some knowledge about Excel, then you can draw this graph in Excel. This is not a very difficult graph. Now going to our next slide. Now we will discuss the analysis of seasonal variations. As you know that our time series data has four kind of variation. Number one is secular trend. Number two is seasonal variation. Number three is cyclical variation, and number four is irregular variation. Now we have dealt with the first kind of variation, which is the secular trend, and we have estimated the trend values, and we eliminate the trend from the data. Now have to deal with seasonal variation. So I can read this for you. After removing the trend from the time series, we are left with deviations. Uh, deviations, I can write this. These are deviations, original values minus trend. These are called deviations. These deviations sometimes are also called seasonal differences, but we only remove the trend component, and the other three component are still present in the time series. Now, in this topic, we will learn how to capture seasonal variations and how to remove the seasonal variations from time series. Now there are two formulas here, one for seasonal relative and the other for seasonal index. This is for seasonal relative and this is for seasonal index. These formulas will be explained how to apply these formulas on the data uh, in the next slide. Now, this 100 represents the result in percentage and percentage. But in the examples, I ignore this factor. Uh, this is a new method. Ignore this factor. We will see that how this formula works. Now going to our next slide. Now there are four commonly used methods for calculating the seasonal indices. Number one is percentage of annual average method. This one. Second is ratio to moving average. This one. You already know how to calculate moving average. So this method will be simple, not difficult. And the ratio to trend method, and trend means the method of least square, and the link relative method. Okay? This method is very simple. This one easy to calculate and easy to understand. Uh, so we will first discuss this method. This one, number one. Going to our next slide. Now, the percentage of annual average method. Uh, for understanding what I have done, I have make four steps of the procedure. The procedure is not very lengthy, but for easy understanding, I created four steps. This method is very simple and most commonly used, easy to understand and simple to apply. The procedure is explained in the following steps. Okay. Calculate yearly average. First of all, we have to calculate the yearly average, not quarterly average. The data will be given in quarters and years. Now, divide the original value of the corresponding average. I will explain when we will solve the example. Now you have to see the steps. Make sure the total of the seasonal indices is 4. When the number 4, when then use the seasonal indexes to eliminate the seasonal effect from the time series. Now the procedure is explained by an illustrative example in the next slide. So we go to the next slide. Now here what I only have taken 1 year for understanding. Uh, Now what we have done, now there is no more years, so I do not have to need any yearly average or quarterly average. Okay, so I what I have done, take a total of the year. Okay, and divide the total by 4 because there are 4 quarters. Now we are left with this average. Now what we will do, we divide this value, whole row by this average. Okay, in the next slide, you can see that this is the step one. This is step one. Step two. Now we calculate the seasonal relatives by dividing the original data by the yearly average. Let's You can see that each value is divided by yearly average and ignoring the multiplied by 100 factor, because I do not want my result in percentage. Uh, I want in fraction. Now we are left with these. Now, since there is a note, since this is only single year, so seasonal relatives, these are the seasonal relatives, are can be called seasonal index. If we have 1, 2, 3, 4 years, then we have to calculate quarterly average. Now there is 1 year, so these seasonal relatives will be considered as seasonal indexes. Now we have to show that the sum of these four is should be equal to 4. Now you can see that it is approximately equal to 4. So we will jump to our next step. Now these are the original values, these four, this one, and these are the seasonal index obtained in the previous slide. Now what we have done, we have just multiplied the seasonal index with the original data, and the result will be deseasonalized data. You can see that in the this graph. You can see that there is two series. One blue one is the original series, and the orange one is the deseasonalized data. ठीक? So this is only 1 year, though, so the picture is not very clear, but you can understand the steps very clearly. So in the next slide, I have taken 3 years. Okay. Now in this is a full question. Uh, in this question, compute the seasonal indices by using the percentage of annual average method. There are 3 years and 4 quarters. Uh, Following the procedure I already explained, you can see that I have calculated the yearly average. Okay, yearly average by summing these values, four values, and divided by 4. We have these averages. Now, what we will do in the next slide, we will divide this row by this value, and this row by this value, and the third row 1998 by this value, and we are left with the seasonal this. Now you can see that I have already divided the values and have results. Now in the second step, I have total of quarterly total. If we divide these values by 3, we are left with the average. Okay, now in the next slide, I have calculated the average. Okay, and also total is equal to 4. These are the seasonal indexes. This is quarterly average, ठीक, which is the seasonal indices. Now we will deseasonalize the data by using these values and original values. This is the deseasonalized data. The method is simple. Original value multiplied by the seasonal index. Uh, Original multiplied by seasonal index, and we will have these values. Okay, now if we plot these values on the graph paper, we have something like that. Okay, and this is the original data and this is the deseasonalized data. You can see that I have put it on the table. This is the original data and this is the deseasonalized data. Hope that I have explained the topic carefully. If you have any questions, any queries, you can contact me through Google Classroom. Thank you and Allah Hafiz.